Hello everyone, welcome to the video, and in this video we are going to look at the chapter polynomials. So what is the meaning of polynomial? Polynomial means any set of terms that is having a variable. So for example, x plus 4, this is a polynomial. This is another example for a polynomial. This is also an example of polynomial. In this particular polynomial, the variable has exponent 2, the power of the variable. In this case, the variable is x. So the power of x is 2. It is called a second degree polynomial. So what are the conditions for a number or a term to be considered polynomial? So there are two conditions. The first one is the coefficient of the variable should be a real number. Coefficient of variable should be real number. And the second condition is exponent should be a whole number. Now let us see some examples. The first one is this is the polynomial that I have chosen for example. So is this a polynomial or not? This is a polynomial if it satisfies these two conditions. So let us check those conditions. Coefficient of variable should be real numbers. So here the variable is u, and coefficient of u power 6 will be 7 real number, minus 3 by 2 another real number, plus 4 real number, plus 1 real number, and exponent should be a whole number. In this case, let us look at the exponents, that is powers of the variable. U power 6 is a whole number, u power 4 whole number again, u power 2 whole number, u power 1 another whole number. So this satisfies the condition. Now let us look at this example, root 3x plus 5. Now is this a polynomial? So here exponent is one whole number, so it satisfies second condition. But what about first condition? Coefficient of the variable should be real. Yes, root 3 is the coefficient of the variable and it is a real number. It is an irrational number, and irrational number is also a real number. So this and this both are polynomials. Let us look at some more examples. So these are three different examples, among them which are polynomials and which are not polynomials. So let us look at the first example. The first condition is the coefficient of variable should be real number, so it satisfies. The coefficient of x here is 1, it's a real number. But the second condition, the exponent should be a whole number, but in this case the exponent of x will be minus 1 because x is in the denominator. We know that when a to the power minus 1 will be 1 by a, and x is of that form. So the exponent of x here is not a whole number. Hence this is not a polynomial. Now let us look at this example. All the coefficients are real numbers and all the exponents are whole numbers. So this is a polynomial. And this example, the coefficients are real but the exponent of x here is not whole number. This can be rewritten as x to the power 1 by 2 plus 2. 1 by 2 means square root, 1 by 3 means cubed root, and so on. So here the exponent of x is 1 by 2, which is not a whole number. We need the exponent to be a whole number to call this a polynomial. So this is also not a polynomial. I hope everybody got a clear understanding of what polynomial means. So now a small question for you. 6. Is this a polynomial or not? I just wrote the number 6 and I'm asking you if this is a polynomial or not. I will explain if this is a polynomial or not after a few minutes. And if you have any opinion about this, you can put it down in the comments right now. If you think this is a polynomial, comment yes. If you think this is not a polynomial, comment no right now. So now we can see what is the meaning of value of a polynomial. So usually polynomials are represented like this. So this is the polynomial. F of x means function of x is equal to x plus 5. Now the value of a polynomial. So this is the polynomial, and value of polynomial is when you substitute any number, any value for x, and whatever value you're getting for the polynomial, that is called value of the polynomial. For example, when x is equal to 1, so f of 1 will be 1 plus 5, which is equal to 6. So when x is equal to 1, value is equal to 6. Clear? When we substitute any known value for the variable, what is the value of that polynomial? That is called value of the polynomial. So now we can look at the another concept which is called zero of a polynomial. So we know when we substitute any value for x, whatever the polynomial's value is called value of the polynomial. But when for any x equal to k, any value of x, we get value of polynomial as 0. Then k is called 0 or root of the polynomial. Let us look into this with some examples. Take this polynomial, for example, 2x plus 7. So our f of x is 2x plus 7. This is the polynomial that we have chosen. Let us try substituting minus 7 by 2 here. So when x is equal to minus 7 by 2, f of minus 7 by 2 will be 2 into minus 7 by 2 plus 7, which is equal to minus 7 plus 7, which will be 0. So minus 7 by 2 is a 0 or root of this of polynomial. So for every polynomial there may be a root or there may not be a root, depends on several conditions that we will discuss very soon in this video. So now we understood what is the meaning of value of a polynomial. We understood what is the meaning of 0 of a polynomial. Now we will discuss degree of a polynomial. A degree of a polynomial is the highest power of the variable. So for example, x cube plus 3x square plus 5x plus 7. We have this polynomial and the degree of the this polynomial is the highest power or the highest exponent of variable. So in this case it will be 3. So degree is 3 for this polynomial. Now we can take another one example. And what about the degree of this polynomial? It will be 2. The highest power of the variable x is 2. So degree is 2. Now let us come back to 6. We were discussing whether 6 is a polynomial or not. But I can write 6 as this, right? 6 into x to the power 0. Now this is a polynomial. Why? Because exponent of the variable is a whole number. 0 is a whole number. And also the coefficient is real. So 6 is a polynomial with degree 0. So I hope everyone understood value 0 and degree of a polynomial. Now let us discuss how a polynomial will look in Cartesian plane. What is the meaning of Cartesian plane? This is a Cartesian plane. Cartesian plane means basically a graph. So now let us write a polynomial, an example polynomial. We can take x plus 3. Now how can we represent this polynomial in this graph? So let us consider y is equal to x plus 3. Now we can make this tiny little box. Let's do it over here. So here we can write down the values of x and corresponding values of y. So y is equal to x plus 3. What happens when x is equal to -2, -1, 0, 1 and 2? So let us check it. When we put x is equal to -2, we are getting y as 1. And when we put x is equal to -1, we are getting y as 2. And x is equal to 0, y is 3. And x is equal to 1, y is 4. And when x is equal to 2, we are getting y is equal to 5. So now we can plot this graph. -1 will be here and -2 will be here. So -2 and y is 1. This is the first point. -1 and y is 2. Second point. 0 and 3. Third point. 1 and 4 is 4 point. And 2 and 5 will be somewhere over here. So we are getting a straight line. Now look at this point. This is the point where the line is touching the x-axis, otherwise the line where x is 0. X-axis, what is the meaning of x-axis? The x variable is 0. So this line is crossing x is equal to 0 at -3. If we try to solve this x plus 3 polynomial and try to find the 0 of this, how can we find the 0 of this? What value should we substitute to get this one as 0? That is, we need to get x plus 3 is equal to 0. Then that means x should be -3. So when, sorry, this is not x is equal to 0, this is y equal to 0. X axis. So at what variable of x, when the value of the polynomial is becoming 0, that is called 0 of this whole polynomial. So this line is the polynomial which can be represented like this: y is equal to x plus 3. It can be represented as a line in the Cartesian plane, and this line where it crosses the x-axis or where it crosses y equal to 0, that point is called the 0 of the polynomial. So this is how polynomials are represented in Cartesian plane or in a graph. But this is a first degree polynomial. X plus 3 is of degree 1. So degree 1 polynomial gave us a straight line. Now let us see what happens for degree 2 polynomials. This is a Cartesian plane, x-axis and y-axis. And now let us fill the values for y-axis also. Okay, now we are going to write some example for degree 2 polynomials. Let us consider this example, the simplest of all the polynomials, all the degree 2 polynomials, x square. So in order to make this into a graph, we need to take it for y is equal to x square. So when y is equal to x square, we can make this box. So here we can write down values of x, and here we can write down values of y. -2, -1, 0, 1 and 2. And for y, when x is equal to -2, y will be 4. When x is equal to -1, y will be 1. Here 0, and here also 1 and 4. So -2 and y is 4, -1 and y is 1, 0 and 0, 1 and 1, 2 and 4. And we can join it with such a curve. This curve, technically it should pass through this point. I just made it roughly. So we can see a U-shaped. So for degree 2 polynomials, always produce U-shaped, U-shapes, or this U-shape is called parabola. Degree 2 polynomials will always produce a parabola in the Cartesian plane. So we can continue this in the next video.